usually not in front of the camera. I'm normally behind, but today I'm going to step out here and show you what's going on with geothermal. I'm here with Brian Erdahl from Jacobs Heating and Cooling. They're in the middle of installing a new system up in Sylvan Hill. Brian, thanks for joining us.
Not a problem. My pleasure.
Tell us what's happening back here.
Well, what we have here is a drill rig that's going to be putting in a 150-foot ground loop. What we got is an older home built in about 1940. He's actually doing upgrades. He's doing insulation upgrades. He's got a furnace on the lower floor and a furnace on the upper floor. He has a total of 850-foot boreholes on this particular project, and what we're going to do is basically link 4 loops up to the lower system and 4 loops up to the upper system. We'll split it up that way.
How big is this hole that they're drilling here?
This particular project is actually a 3-inch borehole. We're doing 2 3/4-inch feet down the hole for a total of 150 feet. We have 1,200 feet of bore total. We're actually looking at about 2,400 feet of pipe on this project. Basically what we need is enough thermal mass in the ground to basically handle the amount of load of the house. So what we don't want to happen is end up having 100% run times on these systems and freezing the ground.
How do you determine how deep?
What we usually do is we have our outfit here, Geothermal, we work with. They look at surrounding areas of old well log reports and kind of determine what we're going to hit at what depth, and kind of base everything on that. So here what we're actually drilling into is a clay type soil, and anything past 150 we're going to hit basically solid basalt. I originally wanted 200s. We determined 150s to save the homeowner quite a bit of money.
What's the temperature at 150 feet?
In our area, our mean earth temperature is between 53 to 55. It may be a little bit warmer when we get down to the 150-foot depth, but not much. That's what makes these systems so efficient, is you're working with a stable temperature of the ground. So it, unlike an air source where it's the air that's determining how much BTU you're getting out of the system, these geothermal systems are working with a stable temperature, so they get all their BTUs all the time. It doesn't matter on if it's -20 outside or 120 outside.
Yeah, it always struck me as funny on an air-to-air system that you're trying to extract heat out of cold air.
Yeah, and that's exactly the point. It's a pretty simple concept. It's been around since the 1940s, but people are finally looking at it as a good sustainable way to heat their house and save a lot of money on their energy bills.
We're here with Al Jubitz. He's the homeowner installing this system, and the first question I have for you, Al, is why are you doing this?
You know, I'm really excited about this technology. Its efficiency rating is so much better than what I've got. Furnaces are 96% efficient. This is 400% efficient. I can get off fossil fuels in this house. The electric bill will go up, but the way I figure that is that electricity is renewable. Wind and solar.
So I assume you're on the PGE all-wind program?
Yes.
Okay. I understand that there's an added bonus to this besides just heating and cooling your house.
Oh, the hot water, that's a bonus. You know, a lot of the gas bill goes to heat hot water, and I've looked at tankless hot water heaters, and I like those. But this byproduct of this heating or cooling system is hot water, so that's another benefit.
It's pretty commonly known that these systems cost a little bit more than your air-to-air or your gas furnace. How long do you expect it'll take to recover your investment?
I think it's about 14 years.
14 years.
With the incentives and with the power saving. Don't hold me to that, but it's close enough to make me want to do it. This stuff is for real. It really works.
So Brian, we're looking at the pipe that's going to go in this hole. Unfortunately, they hit some rock back there, so
Yeah.
It's not going to go in today, and we're going to miss that. But tell us a little bit about this pipe. This isn't your average PVC, is it?
Well, not exactly. This particular pipe is a HDPE poly pipe. The HDPE stands for a high-density polyethylene pipe. It's designed to withstand the expansion and contraction of the pipe between the heating and cooling season.
In the heating mode, we're constantly extracting heat from the ground, so our loop temperatures can see 32 degrees. So at that point, we need a type of antifreeze to make it to where the water doesn't freeze. And so as we're extracting that heat out of the ground, we're running that through our refrigerant to water exchanger. So what happens is we extract all the heat out. As we're extracting, the water gets cooler as we're putting it back into the ground. And same with heating. We can get up to 90-degree water temperatures in the cooling mode, because at that point we're rejecting the heat back into the ground.
As you can see, we actually have a U-bend already on the end of the pipe, and this particular length here is already measured out in a 200-foot length to go down in the borehole, so they know that the pipe has actually hit the bottom of our bore after they're done drilling.
We're not going to see it going in the ground. We're going to have to imagine that. Right now, we're going to go to a new house that's under construction and take a look at the mechanical side.
That sounds great.
Thanks a lot for showing us
Not a
your
problem. My
project.
pleasure.